Welcome to Hartman Math. This is lesson 7.1, Systems of Equations. Our technique is going to be graphing. So think about this question. What are some of our techniques, our methods for graphing equations of lines? Pause here, think about it, come back, see what we got. So most of the time we've got our y equals mx plus b style, where we start with the y-intercept, plot that on the y-axis, then do rise over run for our slope, get our 2 points, draw the line. We also have cover-up method for finding the x and the y-intercepts. Usually if the equation is in standard form, or the x's and the y's are both on the same side. And then we also had special lines. We had horizontal and vertical lines. Those are some of the different lines that we have graphed. So in this case, with the system, we're going to have more than one equation, so we're going to be graphing multiple lines, generally two. For example, here's our system. We've got two equations. We want to solve the system by graphing. So what we're going to do is we're going to graph each line, see what happens. We're going to start with this one, our top one, y equals 3/2 x minus 2. That is in y equals mx plus b form. So let's start with the y-intercept, -2 on the y-axis. And then let's do our slope. Rise 3, run 2, up 3, always go to the right. Put a point. Now, when we're just graphing a single line, a lot of times that's good enough. If we're graphing and doing a system where we're going to be graphing multiple lines, we need these to be very exact. So, I might recommend we might want to actually do that again, where we did the up 3, right 2. Do it again, because the further we can get our points spaced out, the more accurate the line is going to be. So we might have put a point there and then have a very accurate line. All right, for the next one, this is in standard form. And I think we could do the cover-up method. If we cover up the y and solve for x, x equals 4. We put that on the x-axis. And then if we repeat and cover up the x part, go ahead and solve for y. Y equals 2. That goes on the y-axis. Draw the line. Now when we say we're going to solve, we're looking for where did the two lines intersect. So we're showing it here on the graph. And then we have to answer that in terms of an ordered pair. Right 2, up 1. So the solution, we're always going to write it as a point. Points have parentheses. Parentheses 2, comma 1 is our solution to the system. It means that it makes both of the equations true. We could check it if we wanted to. Plug in a 2. 3/2 times 2 is 3. Minus 2, we get 1. Y is 1. So it works there. 2 plus 2 times 1 equals 4. That checks out as well. So it does work in both equations, and that's what we're looking for. Write the answer as a point. Example number 2, let's do another one. Y equals x. It has both x and y, so it's not special line. And y is by itself, so this is probably slope-intercept. Y equals mx plus b. It's a little bit tricky though. What's the b? Well, the b is after the x, and we don't see it, and it's plus b, so what would we add that we wouldn't see? It's a 0. So we got a y-intercept of 0. Now we're ready to do the slope. Rise over run. The slope is in front of the x. It's also invisible because it's multiplication. That one's a 1. That's a 1x. So our slope is 1. Turn that into a fraction, 1 over 1, up 1, right 1. Those are very close together, so we probably want to do that a few more times. Up 1, right 1, up 1, right 1, and get these points spread out before we go to draw the line. Definitely want to be doing this on graph paper. All right, now this one doesn't have an x, so that one's a special line. Y equals is the horizontal kind, so we're going to go to -3 on the y-axis, and we're going to go horizontal. All right, here's where they intersect. Make sure we're real careful about it. And now as far as location, left 3, down 3. There's our solution, -3 comma -3. Let's try it out. -3 equals -3. Replace the y. -3 equals -3. Works in both. There's our solution. Example number 3. Y equals mx plus b. That one should be an easy one for us to graph. We're going to start there on the y-axis at +1. Slope is 2. That's the same thing as 2 over 1, up 2, right 1. Maybe we do that again to get a very exact line. Now this one is not in the form that we're familiar with. We don't really do x equals when it has x and y. If it was x equals number, that would be a special line. But this one isn't. So I think we're going to want to do some algebraic work on this. See if we can get the y by itself, so then it's a y equals mx plus b graph. So I'd say we want to get rid of the +1. And now how do we get rid of the half? We really don't want to divide by a fraction. Maybe we could multiply by something, like the reciprocal. Multiply both sides by 2. If we do that, the 2 will distribute on the left side. You have to multiply all of it by 2. There we go. Now it's in a form where we can graph. Y equals mx plus b. Start on the y-axis at -2. Up to right 1. Maybe do it again. I don't think those intersect. In fact, I think they're parallel. Because as we kind of see here, they do have the same slope, but different y-intercepts. And that's algebraically definitely going to mean they're parallel. They're not going to intersect. So as far as a solution, since they don't cross, there are no points on that lie on both of the lines, our answer in that case is going to be no solution. If it was the same line, let's say one was right on top of the other, and all these points would work, we would say something different. In that case, we would say infinitely many solutions. All right, let's graph. This one's ready to go. Y-intercept. Slope. Down 3, right 1. Now, if you had more room, we could do that again. I might reverse this. If I went down 3, right 1, how about we go up 3, left 1? That kind of continues our pattern to get a more exact line. I think this one we could do cover up. Cover up, solve for x. X equals -1. Cover up, y equals, solve for y. Y equals -3. Ooh, here it is. Graph that. It's the same line. So this point's on both, this point's on both, that point's on both, that one's on both, that one's on both, that one's on both. So there are infinitely many solutions. That is not the same thing as all real numbers. Different. It is infinitely many solutions. That's it for today. I'll see you next time.